Pseudo force technique, that is frame of reference. It is the body, person or observer related to which the motion of other body is analyzed or discussed. Inertial frame of reference. The frame of reference which remains at rest or moves with constant velocity is called inertial frame of reference. Newton's law of motion is applicable in this frame of reference. Till now, the problem have been solved in the inertial frame of reference. Now, non-inertial frame of reference. When the frame of reference moves with an acceleration, it is known as non-inertial frame of reference. We cannot use Newton's law of motion in this frame of reference directly. To use Newton's law of motion in this frame of reference, we have to apply a pseudo force equal to the product mass and acceleration of the frame opposite to the direction of motion of frame of reference. And this is called pseudo force technique for solving problem. For example, here a lift, a block A is placed in the lift and lift is moving with, in upward direction with acceleration a naught. Now we have to analyze the motion of block. When the observer is at ground, that is, it is in inertial plane, then we can apply directly the Newton's law here. So for drawing the FBD of block A, there will be a normally action in upward direction, weight of the body will be acting in the downward direction. Now this body is moving with acceleration because lift is moving with acceleration, so body will also be moving with acceleration with respect to ground. So we can use Na minus Na into G equals to Na into N. From it we get normal force on block A, Ma into under bracket G plus A naught. This is equation 1. Now consider observer in left non-inertial frame, and we are now not using the pseudo force technique. Then for observer in the block, that is here is observer, he see that the block is in rest, so he will use directly n dash minus nb mn to g equal to 0, hence which gives him na dash equal to ma into g. So na is not equal to na dash a. So both observers zero force for the observer in ground and observer in the uh, lift, the normal reaction is not equal to each other. So to solve this problem from lift, we apply a pseudo force equal to m into a naught on block A in the downward direction. We do so because we have to make lift inertial frame. Now here is the situation is shown. The normal force is Na dash in the upward direction, weight of the body is in downward direction Ma into G, and a pseudo force Ma into A naught has been applied on the body, which is Ma into A naught. Now we can apply directly Newton's law in this situation. So for observer in left now, block A is at rest, so Na dash equals to Ma into A naught plus Ma into G, or Ma into A naught plus G. This is question 3. So from 1 and 3, Na equal to Na dash. Here Na, Mag are real forces, and Ma into A naught is pseudo force, which is used to make the frame inertial. Example, find the minimum horizontal force F required to keep the block M stationary with respect to wedge capital F. To solve this problem, first directly from the observer at ground, we see that let's consider both bodies moving with acceleration A, then we have A equals to F by M plus F, because net force is acting on both system is F. So we have got A. Now using the Now from the inertial frame of reference, that is from ground, we are seeing the body on the ground. The FBD of block M will be, that is only write real forces, not apply here pseudo force. The normal force N in this direction, force of friction in upward direction, weight in downward direction. So sigma Fx equal to Ma into x, N equals to Ma, and sigma Fy equals to 0. So F minus mg equals to 0. Now F barabar mu n, so mu n equals to mg. N equal to mg by mu, equation 3. Now from 2 and 3, Ma equals to mg by mu. This implies A equal to g by mu. Equation 4. And from 1 and 4, because we have got A equal to g by mu, and from 1 we have calculated acceleration. So from 1 and 4, F by m plus m equal to g by mu. Hence F will be g by mu into m plus m. Answer. Now considering non-inertial frame of reference, that is observer on block capital M. Now for observer on block M is at rest. Block of a smaller mass, M is at rest. Now FBD of M, for FBD of M we have to write real plus pseudo force. Hence here it is shown. So sigma Fx equals to 0 gives N equals to Ma, and sigma Fy equals to 0 gives F equals to mg, or mu n equals to mg. From A and B, mu Ma equals to mg is A equals to g by mu c. So from 1 we get F equals to m plus m into A equal to g by mu into m plus m. Answer. Example: all surfaces are smooth in following figure. Find F such that block remains stationary with respect to base. Solution: acceleration of the block plus weight equal to A equals to F by m plus n. Now initial frame from ground, FBD of block is shown in the figure. Because n is in this direction, so this in n sin theta, and this will be n cos theta. Weight in this direction, so this will be mg sin theta in this direction and mg cos theta in this direction. Now sigma fx equals to 0, so n cos theta equals to mg, and sigma fy equal to m into y. So n sin theta equals to ma, 3 and 2 tan theta equal to a by g, hence a equal to g tan theta, hence f equals to m plus n into a, m plus n into g tan theta. Answer.